Okay. After discussing the procedure for finding maxima and minima for a function in more than two variables, let's discuss one problem. This is a different one. Normal ones, anyways, you can do using the procedure or the working rule. This is a different problem where it's been given that a rectangular box open at the top has a volume 32 cubic feet. Find the dimensions of the box requiring least material. Note, guys, nothing about maxima minima has been given here. There's one word related to extreme value or maxima or minima, that is the least material required. Just a second. The least material required for its construction. By the way, suppose, see, I'll just consider a cardboard box. Please see here. I have a cardboard box. It's been given that it's a rectangular. So I have considered a cuboid, guys. Not a cube, it's a cuboid where the length, breadth, height are different. Let them be X, Y, and Z. Okay. Now it's been given that volume. Volume of a cuboid. What's the formula for volume of a cuboid? It's a LBH, right? Volume of a cuboid. LBH, it would be X, Y, and Z. Okay, this is fine. But what's been asked, find the dimensions of the box requiring least material for its construction. Suppose if I have to find the dimensions of the dimensions of the material required for the construction of the box, then I will be needing the surface area because box means what? Inside the box, there will be nothing. Surface area. Box would be, how will the box be? In between, inside the box, there will be nothing. It will be enclosed by six surfaces. Okay. But then the box is open at the top. So I can just remove one surface. So it'll be having five surfaces. Now, if I find the surface area of a cuboid, how will it be? It's a rectangular box. So every surface in 2D will be something like, if it is the length into breadth, then it is xy, 2 times of xy, because one is this side, the other is its opposite side. Then 2 times of yz and 2 times of zx, right? Now, 2 times I will remove, any 1, 2 I will remove because the top is open. You can consider any one surface to be not there, okay? So it's enclosed by 6 surfaces. Now, what I need exactly is this one. Since it is open at the top, I'll just write the condition here. Since it is open at the top, okay? Now, what exactly I need to find is not the volume, minimum of, what I want to find is minimum of, I can as well take xy and then I can put 2, or I can as well take 2xy plus yz. Anything is fine. Minimum of xy plus 2yz plus 2zx is what I want to find out. Okay. What's the condition that I have is volume of the cuboid is given to be 32 cubic feet, right? So actually to find maximum and minimum, the procedure that I have is a function in 2 variables. But here it sounds clearly that the function is in 3 variables x, y, and z. So I have to remove one variable using the condition that the volume of the cuboid. Okay. What I will do, I'll take like z is equal to, this is equal to 32. So z is equal to 32 by xy is what I will take. Or anything you can take. X is equal to 32 by zx, or y is equal to 32 by zx, or x is equal to 32 by zy also you can take. Okay. So xy plus 2y, z in place of z I'll be writing 32 by xy plus 2 into 32 by xy into x is what I will take. Now this is transformed to a function in 2 variables. Now I can go with the procedure. Okay. With the procedure that I have described earlier in the previous video. Okay. This is my function. This is my function f of x comma y in 2 variables. Now what I need to find is fx and fy, right? Fx, what is that? Dou f by dou x is what I need to find out. Okay. I can just cancel out x here. I can as well cancel out y here. Right. Now, xy I have derivative of x is 1 and 2y plus 2 into 32 is 64 into 1 by x derivative with respect to x would be minus 1 by x squared, guys, plus this is 232 are constant. At the same time, y is there. Y is a constant with respect to x as well. So this is 0. So finally, I have this is equal to 0 because the necessary condition for finding maxima and minima is equating the first order derivatives to 0. So finally, I have the equation to be y minus 64 by x squared is equal to 0. I have a value for y in x. I look at that later. Now I'll as well find fy. That would be what? Dou f by dou y. Right? In xy, x is treated as a constant. Y derivative is 1. Right? And then 2 is a constant. 32 is a constant. X is also a constant. So this term derivative with respect to y would be a constant. Now 2 into 32 is 64 into 1 by y derivative would be minus 1 by y squared. Okay. And this is equated to 0. Why? Because the necessary condition is that. So finally, I have x minus 64 by y square is equal to 0. I have to use 1 and 2 equations, guys. Solving 1 and 2 in any possible way of your choice. There's no hard and fast rule that this is the way you should solve. Either you take y value from here, either you take x value from here, substitute one and the other. Solve as you like. Okay. Get the stationary points. Okay. We can as well substitute the value of y is equal to 64 by x squared. Okay. I can substitute the value of y, which I obtained from equation 1 into 1 and 2. What I will get? X minus 64 by, what's the value of y? 64 by x squared. So y square would be what? 64 whole square. Denominator by denominator goes to the numerator. It is x square whole square, guys. Because it is y square. Okay, 64 and 164 goes off. This is equal to 0. Then I'll be having what? If I take the LCM, 64x minus x power 4 is equal to 0. Don't cancel out any x value. Why? Because, yeah, don't cancel out any x value. Why? Because I'll be needing the points, stationary points. So neither x, no variable should be cancelled out. Constants can be cancelled out, but please don't cancel out the variables. Okay, just take out x common from this. So I'll be having what? X cube minus 64 is equal to 0. Or I'll be having x is equal to 0 as one root. Another root can be, it is like a cube plus b cube, a cube minus b cube, guys. The formula goes like this. A minus b into a square plus ab plus b square. Okay. Now a square plus ab plus b square would give me imaginary roots, which I will skip off. Okay. I will just consider this part where x minus 4, a is x. Okay. 64 is nothing but 4 cube. So x minus 4 is equal to 0. I will take x would be 4. Okay. If x is 4, let's find out what is y. Okay. What is y actually? Y is equal to 64 by x square, right? X, if 64 by x square, 64 by 4 square would be what? 16. So y would be 4. So for x is equal to 4, for x is equal to 4, y also is 4. 4 comma 4 is a point that I have. Okay. 4 comma 4 is the point that I have. This is the stationary point that I have. If any other points are there with contradictions, I'll just skip them off. Okay. Now I'll be finding out r, which is nothing but fxx or double derivative of f with respect to x. What will it give me is r would be 128 by x cube. You can just verify. I'll come back to this screen once again. T would be what? Double derivative of f with respect to y. Already one derivative I have found out. Another derivative I'll be doing with respect to y only again. Okay, 128 by y squared. S would be what? I'll be having it to be 1. I'll just scroll up to show you how I have got these values. Yes, please see here. Fx. I'm doing x derivative. X derivative once again with respect, fx derivative once again with respect to x. So y, with respect to that, y value would be 0. Yes or no? Y value would be, derivative of y with respect to x would be 0. Minus 1 by x squared derivative would be what? Or 1 by x squared derivative would be what? 3 into x cube. Okay, minus 3 into x cube. Minus of minus becomes plus. 64 into 3 would give me 128. 64 into 3 would give me 128. Okay. And then I'll be having 128 by x cube. And then this one. Okay. Come to the previous. Yeah. What I will do is fx I can do with respect to y. Right. Now, a derivative of y with respect to y would be 1 and then x term would go to 0. So, fxy is 1. Now, fyy, again, I'll do the derivative with respect to, yeah, I'll do the derivative with 2 into, I'm sorry. I'll do just here so that you understand. Okay, x derivative is 0 with respect to y. 64 is as it is. I have y power minus 2, right? So, y power minus 2 would be what? Minus 2 into y power minus 2 minus 1. Yes, guys? Right. Minus of minus becomes plus. 64 into 2 is what I will have. Y power minus 3 is what I'll have. 64 into 2 is 128. That's how I have got 128. Now, RT minus S squared is with me. I have the stationary point 4 comma 0. So, I'll be finding out RT minus S squared now at the point 4 comma 0. Okay. Now, RT is what? 128 by x cube into 128 by y squared minus S squared would be 1. Okay. Y cube only. This also is y cube, not y squared. Okay. This also would be y cube only. This also would be y cube. Okay. I'll be substituting the point 4 comma 4. Okay. X is 4, y is 4. So 128 by 4 cube would be 64. 128 by 4 cube would be again 64 minus 1. Okay. So obviously, guys, this would be greater than 0, right? This is such a huge term. So this would be greater than 0. You can just calculate what the value turns out to be like. Okay. Or I can just say this would be what? 2 into 2 minus 1, which is nothing but 4 minus 1, which is 3 greater than 0, right? At the stationary point. Now I'll be finding R at 4 comma 4, guys. What is R? It is 128 by x cube, which is 4 cube because x is 4. Okay. So 4 cube would be what? 128 by 4 into 4 into 4. Okay. 4 3 is 12. 4 2 is 8. Okay. Yeah. 4 8 is 32. Okay, 4 2s. So I'll be getting R to be 2, which is again greater than 2. So if R, see, as well I can find, this is not mandatory that it should only be R, guys. It can be T as well. Okay, what is T? 128 by Y cube, na? Y cube at 4 comma 4. Y is again 4 only. So 128 by 4 cube again would give me 2, which is greater than 0. Now for R greater than 0, see here, the condition is RT minus S squared greater than 0 and R greater than 0. What will the function have? The function will have a minima, because second order derivative less than 0, the function will have a maxima. Second order derivative greater than 0, the function will have a minima. Minima at 4 comma 4, guys. It is not over. The problem is not yet over. I need to find f of x comma y at 4 comma 4. Only then the minimum value I have to find. Only then the problem is done. Okay. Now what I have, the function is xy plus 2y into 32 by xy plus 232 by xy into x. Okay, of course, I have cancelled out certain things. Right? Now, I'll be putting the point 4 comma 4 where x is 4 and y is 4. 4 into 4 plus 2 into 32 by 4 plus 2 into 32 by 4. Okay. So, finally, the value turns out to be, minimum value turns out to be 2, I think, 2. Okay. Is it 2? The minimum, S is minimum at this point. Okay. Yeah. Or I can just find out the value of Z. What is Z? 32 by XY. Okay. 32 by 4 into 4. So Z value would be what? 2. Okay. So the dimensions for the box, Okay. X is what? 4. Y is also 4. Z is 2. Those are the dimensions required for the least material required for the construction of the box. For the construction of the box with least material. Construction of the box with least material. With least material. I hope this problem is clear. Okay. Least material. Okay. I'll just stop here.